So here we are going to see some functions and their graph. The first one is the identity function. Identity function is a function from set of real numbers to set of real numbers and is defined as y is equal to x. Y is equal to x. Otherwise we can write f of x equal to x. To identify the graph, I will plot it there. Y is equal to x. That is how the function is defined. Okay, so this is the graph of the function y is equal to x. That means this is the graph of the identity function. And you can see the black line represents the identity function y is equal to x. And you can see that the points, you can identify the points, some of the points 0, 0, 1, 1, 2, 2, 3, 3. Similarly, negative 1, negative 1, negative 2, negative 2, likewise, isn't it? So as the name indicates, whenever x takes the value 1, y also takes the value 1. That is why it is called by the name identity function and is defined as y is equal to x, and it is defined from fs from capital R to capital R. To find the domain, as fs from R to R, domain is clearly R. Okay, and what about the range? Can you see in which all points the graph is there on the y-axis? On every point on the y-axis the graph is there. You can see the black line corresponding to each and every point on the y-axis. Therefore, the range is also R. So, y is equal to x is the identity function. Definition of the identity function, domain is R and range is also R. The second function we are going to deal with is the constant function. Constant function is also defined from real numbers, set of real numbers to set of real numbers, and is defined as y is equal to c. C can be any constant. C can be any constant value. If I am taking, for example, I am taking y is equal to, let it be 2. Okay, can you identify the graph y equal to 2? It passes through the point 2 on the y-axis and is parallel to the x-axis. As the function is defined from R to R, domain is R. And what about its range? Range is that value in which the graph is there. The only y value in which the graph is there is the point 2. So the range is the singleton set 2. So I will repeat, the constant function is a function defined from R to R, set of real numbers to set of real numbers, defined by y is equal to c. Its domain is capital R and its range is set c. Okay. The next function we are going to deal with is a polynomial function. Polynomial, you are able to identify a polynomial. In general, a polynomial is defined as a0 plus a1x plus a2x square plus etc. plus anx raised to n. Since we cannot show the graph of a general value, I will show the graph of the function x square. X square is again a polynomial, a quadratic polynomial. You are familiar with, isn't it? So I am going to draw the graph of y is equal to x square. Okay. So this is the graph of y is equal to x square, and the shape of this graph is called a parabola, which you will study in the second year. Okay. So this is the corresponding to each quadratic polynomial, there will be a graph. Here the polynomial which we took is x square and the corresponding graph is like this, and the shape of this graph is called a parabola. The range of the function and the domain of the function, we have to check it from the graph. Can you identify the domain? For all x values the graph folds, isn't it? It is U-shaped, U in the sense it is actually extending to the right and to the left. So it is defined for all x values, therefore domain is capital R. Okay, what about the range? Range means we have to find the y values in which the graph is there. Negative axis, there is no graph on the negative axis, but there are values to all, there is graph to all corresponding y values. Okay, so therefore the range will be positive real numbers including 0. Okay, that means it's not a negative real number. Positive real number including 0 we will say as non-negative real numbers. Okay, so here the domain is capital R and range is non-negative real numbers. It is just an example. Any polynomial can be drawn like this, and we will be getting a corresponding graph for the function, and the range varies according to the polynomial which we are selecting. Here we selected the polynomial x square, and so the domain is R and the range became non-negative real numbers.